Rational functions and asymptotes. A rational function can be written in this form. Rational functions are f of x equals the numerator of x over the denominator of x. So we're talking about finding asymptotes of fractions, basically. Okay. Let's talk about this. Finding the domain of something. Domain goes with what? X, the x-axis. How far does it travel on the x-axis? Range goes with how far it travels on the y-axis. So when we're setting these things up, we have to figure out what the domains of. Finding the domain of a rational function. If you have a function, f of x equals 1 over x, just a simple standard function, okay? I have to first figure out what the domain of this is, okay? What do you know about fractions? What do we know about fractions and their denominators? It can't be 0. So in this case, what do you think the domain is going to be? Anything but 0. I can have negative numbers. I can have positive numbers, okay? So because the denominator is 0 when x equals 0, the domain of f is all real numbers except 0. So the domain of this function is all real numbers except 0. So basically, when we are finding the domain of rational functions, we are taking the denominator, setting it equal to 0 and solving. And when it equals, it cannot be, because that's when it would come out to be a 0. Okay? So that is the function of that. Now, when we graph f of x equals 1 over x, how does that turn out, that graph? Try plugging it in your calculator and tell me. When we graph that, what does the graphs look like?
You've seen it before this year, I think.
We have seen it before this year. Okay, Drew says, so basically it creates a graph that goes here, right? And it creates a graph in this quadrant that goes like this, okay? It's not crossing through anything. It's never hitting 0. I have 2 different segments. So if that graph becomes negative, what do you think is going to happen? It's going to flip which 2 quadrants it's in, okay? It's going to flip the 2 quadrants. So it's going to be in this quadrant and it's going to be in that quadrant, okay? So let's talk about finding the domain of some other functions. Let's say you have f of x equals 3x over x minus 1. How do I find the domain of that? You can plug it into your calculator also first if you would like. Take a look at what that looks like and kind of discuss what that means. Make sure that you put parentheses around everything. So parentheses 3x divided by parentheses x minus 1.
It goes through the origin on mine.
Right, it's going to go through, so when I graph this one, it's going to look a little different. It's going to come here, and then it's going to drop there, right, and come through that 0, and then it's shifted this way, okay? Because that 3 and that negative 1 do some things for this graph. So yes, it goes through the 0, 0, and if you use the trace feature, you can see where it does not hit and what goes on there. If you press second and graph to hit the table feature, you can see inputs and outputs, which makes it very nice. If I take this bottom portion, x minus 1, and set it equal to 0, what can x not equal?
1.
Positive 1. Does it ever cross through positive 1? No.
And if you take a look at the graph, you can see that at +1 is where the turning point happens. Okay, the turning points happen at +1. So here's +1, and it starts to turn right there because it's not going to cross through this +1. It's going to turn and never hit there. Okay. Now, okay, vertical and horizontal asymptotes. So an asymptote is where we have turning points and where graphs do not cross through, okay? So there are four main types of asymptotes, or four kind of main rules we can talk about. If the function of x, okay, as it approaches negative infinity, okay, it's going to approach negative infinity as x approaches 0, okay, negative 0. So it's going to decrease without bound as x approaches 0 from the left. Okay. We also know that our functions, okay, are going to approach positive infinity as x approaches positive 0, meaning it will increase without bound as x approaches 0 from the right. Okay. Then we have, that's, so that's part of our asymptotes. The line x equals 0 is a vertical asymptote. So on this original function, the line x equals 0 is my vertical asymptote. Okay. The graph of f, as shown over there that we talked about, has a horizontal asymptote. Okay, of y equals 0 also. So here it's never crossing here, and it's never crossing here, which allows me to have a vertical and a horizontal asymptote. My vertical asymptote is x equals 0. My horizontal asymptote is y equals 0. So it's opposite of how you think usually, right? Horizontal, we think with x. But remember, when we make a horizontal line, it's because it's going through y equals something. Okay? And when we go through, when we create a vertical line, it's because it's going through x equals something. Okay, so then we have also that as f of x approaches 0, x is going to approach negative infinity. Okay, that means that the f of x approaches 0 as x decreases without bound. And then we have the opposite as well. We have f of x approaches 0 as x approaches positive infinity. F of x approaches 0 as x increases. Without bound. Okay. So and we have some guidelines and some rules as to how to follow these things. The line x equals a is the vertical asymptote. The line y equals b is the horizontal asymptote. Okay. We have different graphs we discussed last year. We discussed parabolas, hyperbolas, ellipses, all of those fun things. Yes?
Yes.
Okay. Well, we're going to have to be able to identify their asymptotes and what's going on. Okay. So if I have the function f of x equals 2x plus 1 over x plus 1. What is my vertical asymptote? Where does my vertical asymptote come from? Yes, from the denominator. It comes from the denominator. So when I'm finding my vertical asymptote, I'm setting my denominator equal to 0. Okay? This is my vertical. Okay, so I'm going to say x plus 1 equals 0. X cannot equal -1. That's my vertical asymptote. When you find your horizontal asymptote, you have to look at the x's. Okay? In this case, the x up above on the numerator and the x below have the same power. Okay? If they have the same power, you take whatever this number is over top of whatever that number is, and that's how you get your asymptote. So I'm going to take 2 over 1, okay, which gives me 2. So that's my horizontal asymptote. Okay, if I have f of x equals, thanks, Ben, 4 over x squared plus 1, okay? If I have that, okay, do I have a vertical asymptote? Or how would I find the vertical asymptote? I would take this bottom portion and I would set it equal to 0 and solve. So I get x squared equals -1. Can I have a negative radical? No. So in this case, there isn't a vertical asymptote, okay? Because I can't have a negative in my radical. Now, is there an x up here? No. So my horizontal asymptote is going to be 0. Okay? If there's no x up above, my horizontal asymptote is 0. And that's all I would have to label because there's no vertical one, so I don't have to tell what it is. And there's the horizontal is 0. One more to look at. Let's say we have f of x equals 2 over parentheses x minus 1 squared. Okay, let's figure out what the vertical and horizontal asymptotes are. Vertical asymptote, how do I figure that out? Set the bottom equation equal to 0. Okay, take the square root of this, take the square root of this, so that I have x minus 1 equals 0. So x cannot equal 1. That's your vertical asymptote. Okay. Now, is there an x up top? No, so what's your horizontal asymptote? 0. And that's how I'm solving for my vertical and horizontal asymptotes. Okay. Let's look at like 2 more. And then we'll do some harder ones tomorrow. Let's say I have f of x equals 2x over 3x squared plus 1. Okay, how do I find my asymptote? What do I do? Okay, vertical is bottom equal to 0. So when I do that, I get 3x squared equals -1 divided by 3, and I get x squared equals -1/3. So what do I know about that? Yeah, I don't have a vertical one. I can't have a vertical one because I can't have a negative inside my radical. Okay, okay, so you see here, up here we have an x, down here we have an x, okay? If I have x's on both, and the power below is larger than the power above, okay, then I also am not going to have a horizontal asymptote, or it can be 0 in this case too. I might have a split asymptote. So my horizontal asymptote is 0. Okay. And then let's do this. F of x equals 2x squared over, yep, x squared minus 1. Okay. So vertical asymptote, x squared minus 1 equals 0, x squared equals 1. That means x cannot equal plus or minus 1, basically, right? Okay, so I have two vertical asymptotes on this one. Positive one and negative one, because when you take the radical of something and it has a perfect square, or just when you take the radical, you have a positive and a negative answer. So these are my vertical asymptotes. I have two. Now, up here, this power is squared, this power is squared. So what do I do to find my horizontal asymptote? You take the leading coefficients and you put them over top of each other. So I take 2 over 1, which gives me 2, and that's my horizontal asymptote. Okay. And then tomorrow we will look at finding other asymptotes with factors that are larger, and we will also talk about finding domain and asymptotes